Hello, my name is Amy Fox. I am a postdoctoral scholar here at MIT, and I'm jointly supported by the CSAIL METEOR Program, as well as the School of Engineering Postdoctoral Fellowship for Engineering Excellence. I'm actually a cognitive scientist by training, and my research centers on how humans use visual spatial representations as tools for thinking. So we can think of this as the ability to look at a graph and draw meaning about the data that it depicts. The ability to use a diagram to solve a problem or invent new kinds of charts and diagrams. To me, these are truly remarkable feats of human cognition that are, in my opinion, right up there in terms of the degree of complexity and sophistication of the way we deploy human language. And so I often think of graphs and diagrams as being their own constrained visual languages. And my goal is to use what we know about human cognition and perception to help designers make visualizations that are more effective towards their communicative goals. Here at MIT, I have the privilege of collaborating with Dr. Arvind Sadaranayan and the Visualization Group. And the Viz group uses data visualization in particular as a sort of experimental playground for exploring how we can augment human intelligence. And I think one project I've been working on that really demonstrates the value of this tight relationship between theory and practice, or cognition and applied cognition, is our exploration of interactive visualizations in exploratory data analysis. Much of what we know about how humans interpret data in a data visualization comes from research on static charts and graphs. So pictures on pieces of paper or pixels under glass. But of course, in the 21st century, we don't just look at our screens, right? We have a myriad of ways that we can interact with information on a computer. We expect that if we move our mouse and hover it over something, that maybe a tooltip pops up and tells us more about what we're hovering over. We expect that we can sort of click and drag to select information, to pan and zoom, or zoom in and zoom out. And you can think of applying any of these interaction techniques that are developed for general user interfaces and apply them to data visualizations in particular. But when you do this, it opens up a whole host of new research questions, both from the perspective of cognition and design. So from a designer's perspective, you might ask, how do I know what interaction technique to apply to which kind of graph in what situation, and how do I tell whether or not it's effective? From the perspective of cognition, we ask, well, if I add this interaction technique to this graph, how does that change what the person sees, how they interpret the information, and then how they might choose to act on the information that they glean? So as I was finishing my PhD in cognitive science, I never expected that I would then be postdocing in a computer science-centered group in MIT CSAIL. It just wasn't sort of part of the identity I had for myself. And so the opportunities that the METEOR program have afforded me have just been really eye-opening and incredibly supportive of my desire to expand my toolkit while remaining sort of agile with respect to what kinds of research jobs I might want to do in the future. I think one thing that's really impressive about MIT in general and CSAIL in particular is even though it has obviously an incredibly rich tradition of being on the leading edge of computation and computational science, it's fundamentally very interdisciplinary, right? Like within CSAIL, you have cognitive scientists, computer scientists. The visualization group is even collaborating with folks in the anthropology department, right? MIT has an anthropology department, and they're fantastic, and they collaborate with computer scientists in CSAIL. And so, although I didn't see myself as the kind of person who wanted to pursue a career in computing, I see that my background in behavioral science and learning science is not a barrier to achieving that kind of career.